Now we will discuss about a compound microscope. We studied that a simple microscope using a single lens has got certain limitation and compound microscope can overcome it. What was that limitation? That the magnification cannot be greater than 9, but this can create magnification of very large values. Why is it called compound microscope? Because it uses the compound effect of two lenses, at least two lenses. In our syllabus, we have to study only about a compound microscope with two lenses. What kind of lenses are we using? Both are convex shaped lenses. Both are. The first one is a convex lens. The first one is a convex lens. Second one is also a convex lens. We use two convex lenses. The one lens will be near the object, another lens will be near the eye. So this is called eyepiece and this is called objective lens. Objective lens is near the object, eye lens is near the eye. Where is the object placed? Object is placed here. Normally, this is called, this point is of the object lens. We will keep it between f and 2f of the objective. Object is placed between f and 2f of the objective. So naturally the image will be created beyond 2f here. Beyond 2f here. Okay. So the first lens called objective lens has the object between f and 2f. So the image is created beyond 2f of the objective, beyond 2f of the objective, and that image, as you studied earlier, is inverted one and it is inverted one and it's a real one. Now the eye lens, the eyepiece will act like a simple microscope. It will act like a simple microscope. That's an important point. What is the role of eyepiece in a compound microscope? Eyepiece is acting like a simple microscope, which we studied previously. And the simple microscope can create a final image between d to infinity. So this can create a final image between d to infinity, and we studied that d for largest size and this is for relaxed vision, strainless, relaxed. So we take only the two extreme points. Okay, and the final image position will depend on the image position, object position of the eyepiece. And what is object for the eyepiece? For the eyepiece, this first image produced by the objective is acting like the object. Real object, first image act like the virtual object for the eyepiece, and eyepiece acting like a simple microscope, and the final image can be at infinity. If the final image is at infinity, then the object for the eye lens must be at its focal point. If the final image is at d, then the object for the eyepiece must be between its focal length and optical center. That is what we studied in the previous case. Okay guys, the important points about compound microscope. First one, it consists of two lenses as we discussed earlier, objective lens and the eyepiece. Which is objective? Near the object. Which is eyepiece? Near the eye. And where is the object placed? What is the object position? It is kept between f and 2f, between f and 2f of which lens? Of the object. That is why object is between f and 2f of the objective, right? And where is the first image formed? Who forms the first image? That is the objective lens. Objective lens will form an image between the objective lens and the eyepiece, in between. And the nature of the first image, in entrance they may ask you like this, what is the nature of the first image in a compound microscope? And we know it should be inverted, it's inverted, real, and it is magnified, slightly magnified. So the eye lens, the objective lens magnifies it. Now what is the object for the eye lens? The first image produced by the object is the object for the eye lens. For the eyepiece, objective's image is the object. The eyepiece act like a simple microscope, and for a simple microscope you can apply all the theory that we studied about a simple microscope. Final image can be anywhere between d to infinity, but we study only this end and that end. D for largest size, infinity for relaxed vision. And then what is the nature of the final image? The final image is virtual. It is magnified and erect with respect to the first image, but inverted with respect to the object. I will show you the diagram. Now what is the total magnification? There are two magnification now, the eyepiece magnifies it and the objective magnifies it. The total magnification is the product of these two magnification. I will explain it. Now angular magnification or magnifying power of a compound microscope, I told you earlier it is a ratio of angle subtended by the image to the angle subtended by the object, but one condition, when both are placed at the least distance of distinct vision. So the angular magnification here m is equal to theta of the image by theta of the object, but condition is that both must be placed at D, both at D. So this is the short thing that you need to remember. The whole definition is here. Angular magnification or magnifying power of a compound microscope is the ratio of angle produced by image to angle produced by object when both are at D. That is the definition. Okay. Now a little different diagram. In NCERT you have a similar one, but this is a different one. This will give you clear idea about where is the objective, where is the eyepiece, where is the object placed, where is the first image, what is the nature of the first image, what is the nature of the final image. And in this case the final image is formed at D because we want large magnification. Okay. So objective eye lens, what is the nature of the first image, nature of the first image, this one, it is inverted. Object on this side, image on this side, so it is a real image, inverted, it is magnified. What is the nature of the final image? Final image is inverted with respect to the object, but erect with respect to the first image. It is enlarged, it is virtual. This can be anywhere from D to infinity. In this diagram it is shown at D. Okay. Now see, this is compound microscope with its final image at D, and that means this eyepiece is a simple microscope with final image at D. So we know the magnification produced by the eyepiece, I call it as ME, is equal to final image is at D. So I should be writing like 1 plus D by F of the eyepiece. That is the magnification produced by the eyepiece. What is the magnification produced by the objective? And we know that we use angular magnification normally when the image is virtual and you can't actually measure it. So this is a virtual image, so we call angular magnification. But in the case of a lens with a real object and a real image, we can use magnifying power, the vertical magnification. And what is the magnification produced by this lens? We know this is the lens, this is the object. So object distance is u0 and this is the image, and the image distance must be, let us say this is the image and this is the lens, so this must be the image distance vu. So the magnification produced by objective lens must be equal to the standard equation V by U. Therefore the total magnification, what is the total magnification? The total magnification is a product of magnification of the objective and magnification of the eye lens. How come? I will tell you. Suppose that this height, the object has got a height of 2 centimeter. Let us say the objective makes it 10 times larger, so that will become 20 centimeter. So the objective made it 10 times larger. Assume that the final image is of height 100 centimeter. Now object is 2, image is 100. So how many times? The total magnification is 50. See, 50 into 2 is 100. But how come you get 50? Because this multiplied it by 10. 2 into 10 equal to 20. And how many times did this multiply? The 20 became 100. So the eye lens made it 5 times larger. So the magnification of the objective is 10, magnification of the eye is 5, and the total magnification is 50, and we know that 50 is nothing but 10 times 5. This is the concept. So the total magnification is equal to magnification of the objective into magnification of the eye lens. So substituting, this gives you VO by UO into 1 plus D by FE. This is the magnification. Now in a certain angle, the object and the final image are inverted. To show that inversion, we may sometimes use a negative sign here, VO by UO into 1 plus d by Fe. Now, I will tell you happy news. What is that happy news? Do not apply Cartesian sign convention here. Simply put their values and calculate. If you want, like suppose, okay, what I am telling is that do not apply Cartesian sign convention here. If you get these values, directly substitute and calculate. But many a times this VO will not be given to you in the question. We have to find out this distance. That is why there is some controversial things in NCERT and certain other books, some comparison. Okay. For that I need to refer to a new diagram. So, the equation is minus V0 by U0 into 1 plus d by Fe or V0 by U0 into 1 plus d by Fe. So, sometimes we use a negative sign, sometimes we will not. Suppose in a question options has negative sign, you can apply this. If the option has no negative sign, just apply their magnitude. Fine. Okay. Now, I will tell you what is that difficulty when you compare NCERT with other books. Okay. Now, this is the compound microscope. Okay. Now, let us study the difference in what is given in NCERT and other books. In certain books, they will give you the distance from the objective lens to the eye lens as L, length of the tube. In a tube, if you fix two lenses, the total length must be L. But in NCERT textbook, they have used L, but with a different meaning. They have taken L as the distance between the second focal point of the objective and the first focal point of the eye lens. The distance between the second focal point of objective to the first point of the eye lens is taken as L. So, you can see that here, this distance, this is taken as L. So, when you do questions, we must be careful about what is L given as, because in theory they have taken like this. In one of the exercises, they have taken L as the distance between the two lenses. So, this should not confuse you. Now, if that part is okay, so when you get L, the term L, length of tube, the definition should be proper. Without that, you may go wrong. Now, the point. We know magnification of this microscope is given by minus VO by UO into 1 plus D by FE, where VO is the image distance of the objective, UO is the object distance of the objective, D is the least distance of distinct vision, and FE is the focal length of the eye lens. Now, where is the image formed with respect to the objective lens? This is the objective lens and the image is here. Image is here. So, this distance is what we call as VO. It is called VO. Normally, in practical microscopes, L will be much greater than focal length of the objective. That means, this distance will be small and the length will be large. Therefore, this VO is taken to be equal to, this VO is approximately equal to L in this diagram. Watch out. If this distance is small, then L will be equal to VO, almost. Watch out. If FO is negligible, then the distance VO will become L. So, NCERT takes this approximately equal to minus L by UO into 1 plus D by Fe as per NCERT. But to apply this, what is L, that should be clearly defined. L is the distance between the two focal points. Which focal point? The focal point of the objective and the focal point of the eye lens. The distance is taken as L, then this is approximately correct. But in many books, the total distance will be taken as L. Total distance is taken as L, then this will give you a slightly different answer. Okay. That you have to be careful. Don't worry, during the MCQ session, we will clearly work out a microscope in that context. Now, what happens if the final image is at infinity than at D? Then the magnifying power, we know the magnifying power is given by magnifying power of the objective into magnifying power of the eye lens. Now, magnifying power of the objective will become VO by UO. if you want to put the negative sign to show the inversion. Now what is magnification of the eye lens? For the final image at D, we know that is given by D by Fe. So this is magnification at infinity for a compound microscope, which is generally not used, because in microscope we want that to be in large size. Okay, and if the magnification is at D, then that is given by minus VO by UO into 1 plus D by Fe. In the MCQ session, we will do problem based on these two conditions, because it's there in NCERT. So these are the two different equations for magnification in a compound microscope. The last optical instrument in our lesson is the telescope, and you know that telescope is an optical instrument which is used to see very distant objects, and these distant objects are actually very large, like sun, galaxies and all. So you want to see them clearly, we use a telescope. Telescopes basically are of two types. One is called refracting telescope and the second one is called reflecting telescope. A refracting telescope, as you can see here, uses lenses, and the reflecting telescope uses mirrors. We will study refracting type astronomical telescope. An astronomical telescope consists of two lenses, objective and eye lens. The one away from you, that is near the object, is called objective, and the other one near your eye is called eyepiece. And the objective, see, you have seen binoculars. Binocular has got small lens near your eye but large lens away from you. That is called objective. Objective has got a large size. Aperture is large. Why? Because the objects are at large distance. If you want to see them clearly, it should have a large light collecting capacity. That's one of the reason why we use large aperture for the objective than the eye lens. There is one more reason which you will study in wave optics. And where is the object? Objects are at large distance, we can say they are at infinity. Now, where is the first image found? Where is the second image found? What is the nature of the image? All these things we will discuss after seeing this diagram. Okay, see here, the object is at infinity. Objective is a convex lens. When the object is at infinity, convex lens will form image at its focal point. And this image will act like the object for this lens. And what is this lens doing? This lens is, the eye lens is doing the work of a simple microscope. That's important. Whether it is compound microscope or astronomical telescope, eye lens is a simple microscope. Eye lens is a simple microscope whose final image can be at D or at infinity. But normally telescopes are used for long time observation, therefore we want relaxed vision, so the final image is at D. So the eyepiece of an astronomical telescope is a simple microscope with the final image at infinity. So with the magnification given by D by F of the eye lens. That is the magnification produced by the eye lens. Okay. Now the nature of the image. The object is at large distance, infinite distance. The first image is here inverted, diminished in size, very small in size. It's real. This real image act like the object for the simple microscope, and the final image is it is like this. It's virtual magnified, and this is erect with respect to the first image but inverted with respect to the object. The final image is inverted. Final image is inverted. Okay. So these points are here. We discussed all these points. First image found by the objective is between the eye lens and the objective, inside the two lenses, between the two lenses. First image is real, inverted and highly diminished. Reason, object is at infinity, so first image must be like this. First image acts like the objective for the eye lens. Eye lens function as a simple microscope, and the final image can be anywhere between the least distance and the infinity. Final image is virtual, magnified, erect with respect to the first image and inverted with respect to the object, just like compound microscope. Total magnification is the product of magnification of objective and the eye lens. both of them magnifies it. Now, angular magnification of a telescope is slightly different from that of a compound microscope. What is it? Only one difference. I told you angular magnification is the ratio of theta I and theta O. Angular magnification is given as theta I and theta O. I told you the image and object must be at the same distance. In a compound microscope the distance was d, but in a telescope the distance is infinity. So, what is angular magnification of a astronomical telescope? It is the ratio of angle produced by the image to angle produced by the object when both are at infinity. So, this definition can be asked in the board examination. Okay. Next, we need to derive an equation. Okay. First of all, try to understand the diagram. This is a objective lens. Light ray from object at infinity is coming. Light ray is coming like this. One light ray through the optical center, which will go straight. This one will converge, this will also converge, and this is the point where you get the first image. And these light rays, this one, see this light ray, suppose this light ray goes through the optical center, this will go straight. Then these light rays will go parallel because we want the final image at infinity. So, this light ray should go parallel. Okay. Now, what is the magnification produced here? It is theta of the image by theta of the object, and both angles are here. Now, this is a principal axis. Our light ray is coming like this and going like this. So, we can say this is the angle created by the object, theta O, and you get see the same angle theta O here. After drawing the diagram, you will understand this. Then this theta, where is this image formed? We know this is at infinity, so this will be formed here at the focal point FO. Naturally, theta O from this triangle, theta O is equal to this. Theta O is nothing but you can see it is h divided by FO. H divided by FO over what is theta I? This is the angle at which the object is seen. See this angle. This angle at which the object is seen. So, theta I is created here, this is also theta I, and this distance must be Fe. Why is it Fe? Because if you want final images at infinity, then the first image must be at the focal point of the eye lens. So, this distance is Fe. So, theta I is nothing but h by Fe. So, this gives you Fo by Fe. This is the magnifying power of a astronomical telescope. The same derivation is done here, Fo by Fe. Naturally, if you want a large magnification, Fo must be much greater than Fe, only then you get a magnification. So, normally telescopes are not operated in other mode, only this mode is operated. When the final image is at infinity, we call it as normal mode of the device, normal mode. What is normal mode? Normal mode means final image will be at infinity. This is a board point. What are the disadvantages of refracting type telescope? I told you earlier the objective lens should have a large aperture to collect large amount of light. So, this is a disadvantage. A large aperture lens is actually a discomfort. That is one disadvantage. To increase the resolving power, I told you, you will learn this resolving power in the chapter wave optics, then you will understand it. So, to have a large resolving power, we need large aperture. This is discomfort. It becomes the size large because it is a lens. And this make a heavy lens. And you know, a lens can be supported only around the edge of it. You can't have a support at the middle. This is very difficult because the lenses are heavy, they are large in size, so mechanical support is difficult. So, this is mechanically not strong, and lenses are expensive to make, you need more money, finishing, polishing, all are difficult. And lenses suffer from chromatic aberration because lenses can have dispersion of light, that chromatic aberration. See, you are watching distant galaxies and a slightest problem in your lens can create a new galaxy in the vision, which is actually not there. A crack in the lens may create a new universe out there. I hope you understand. So, these are the disadvantages. To overcome this, see what is the basic problem? The basic problem is lens. So, can you create a telescope without using a lens? Of course, That's what we call as a reflecting telescope. A reflecting telescope uses mirrors instead of lenses. Not the eye lens, the objective. The objective is made of a mirror. It can be either spherical or it can be a parabolic. What are the advantages of reflecting telescope? If it is a mirror, it can be supported on the entire backside. So it has got a better mechanical strength. Then there is no dispersion problem, so there is no chromatic aberration. Then the spherical aberration is very less because we have only one surface rather than two surfaces of a lens, and less weight and better mechanical support. Advantages of a reflecting type telescope over refracting telescope are these 3 points. So a reflecting type telescope in your syllabus is called Cassegrain telescope after the name of the inventor. And a Cassegrain telescope basically consists of a long tube. Say there is a long tube like this which can collect light. The end of the tube has a concave mirror. So light from distant object can converge to its focal point. Now you can set up an eyepiece here. You can set up an eyepiece and you can watch it from inside the tube. There are designs like this where you have a large tube, there is a mirror and you sit inside the tube and watch. But problem is this will block some part of the light, and this also creates, like if you are watching this during the day, the light focusing here can be very hot. So this is not always possible. So what is done is, instead of keeping an eye lens here, we will place a convex mirror here and we will make a small hole somewhere here, a small hole in the mirror. That means the concave mirror that we use here will be a whole mirror but with a hole at the center. Now this light ray can simply come out through that one. Here you can place a eyepiece. There is an eye lens here. This diagram is shown here. So you can see this is the objective mirror and this is called secondary mirror. What is the purpose of secondary mirror? That is to reflect the light focusing inside to outside, and this is the eyepiece. So you can watch through the eyepiece, then you can see the image. Okay, so the concave mirror will converge light, convex mirror will produce it outward, then you can watch. So this is called a Cassegrain telescope. There is one question in the NCERT exercises about this one, which is actually two mirrors. In IIT JEE you can expect this mirrors, concave and convex mirror, and there is an object somewhere here where is the image created, etc. can be asked based on this. There is no equation, no derivation, and this is generally not asked in the board examination other than 1 mark or 2 mark theory. So be happy with Cassegrain telescope. I would suggest construct a telescope or a microscope at home. Use 2 lenses. It's lockdown period. You can do this also practical. It can be submitted as an activity during a board examination. Try that. Only when you try you understand. So thank you for watching. This is the end of ray optics. Then next class onwards we will have MCQs.